Good morning! For today, we will learn how to illustrate quadratic equations. But before that, let's have a short review on multiplying polynomials. So how do we find the product of a monomial and a binomial? In order to find the product of a monomial and a binomial, we apply what we call the distributive property. Say for example, we have 6x squared times quantity x minus 5. So distributive property, we distribute, multiply 6x squared first by x. Therefore, we get 6x cubed. And then multiply 6x squared by negative 5. The product is negative 30x squared. Therefore, the answer is 6x cubed minus 30x squared. Let's have another one. How do we find the product of two binomials? To find the product of two binomials, we apply the FOIL method. F stands for the first term, O for the outer terms, I for the inner terms, and L for the last terms. So say for example, we have quantity x plus 6 times quantity x minus 7. So using FOIL method, first we multiply the first terms. The two first terms are x and x. So x times x is equal to x squared. Next, multiply the outer terms. The outer terms are x and negative 7. So x times negative 7 is negative 7x. I is for the inner terms. The inner terms are 6 and x. So 6 times x is positive 6x. And then L stands for last terms. The last terms are 6 and negative 7. So 6 times negative 7 is negative 42. As you can see, negative 7x and positive 6x are like terms. Like terms can be combined. So if we combine negative 7x and 6x, the answer is negative 1x, but we simply write negative x. And then we bring down x squared and negative 42. Therefore, the product is x squared minus x minus 42. Next, how do we square a binomial? In squaring a binomial, say for example, we have quantity x plus 5 raised to the second power. We can use the long method, which is the FOIL method. First, we expand. This is the same as x plus 5 times x plus 5. And then apply the FOIL method. So x times x, we have x squared. X times 5, we have 5x. 5 times x, we have 5x also. And then 5 times 5, we have 25. Combining like terms, we have this is equal to 10x. Bring down x squared. Bring down 25. The product is x squared plus 10x plus 25. That if we use the long method, which is the FOIL method. But we have another choice. The shorter way of doing it, or the shorter way of squaring a binomial, is by following this pattern. Okay, as you can see, if you have a plus b raised to the second power, or quantity a plus b raised to the second power, the product is a squared plus 2ab plus b squared. How do we get that? First, we simply square the first term, and then for the middle term, how did we get to AB? To get to AB, we simply multiply A and B and then get twice of it. A times B and then twice of it is 2AB. That is why our second term here is 2AB. And then for the last term, we simply square B, or the second term. So, using the same example, we have x plus 5 raised to the second power. To get the product, first, we square the first term. So, what is the square of x? So, the square of x is x squared. And then, for the middle term, we multiply the 2. X times 5 is 5x. And then get twice of it. What is twice of 5x? Twice of 5x is 10x. And then for the third term, we simply square the second term in the binomial. So 5 squared is equal to 25. So as you can see, we have come up with the same answer as the one here, wherein we use the long method. So you can make use of the shortcut method by simply following this pattern. Next, how do we find the product of the sum and difference of two terms? So we can make use of this pattern. So let me read. The product of the binomial sum and difference is equal to the square of the first term minus the square of the second term. So say for example, we have quantity A plus B times quantity A minus B. The product is simply equal to the square of the first term minus the square of the second term. Say for example, we have x plus 3 times x minus 3. So this is finding the product of the sum and difference of two terms. Actually, you can make use of FOIL method, but you can also apply the shortcut. It is simply equal to the square of the first term. The square of the first term is x squared minus the square of the second term. What is the square of 3? The square of 3 is 9. Therefore, the product is x squared minus 9. Same in this example. If you want to use the long method, yes, you can still apply FOIL method. But if you want to use the shortcut, we can apply this. This is simply equal to the square of the first term. The first term is 4x. So get the square of it minus the square of the second term. The second term is 3. Okay, what is the square of 4x? 4x times 4x is equal to 16x squared minus the square of the second term. The square of 3 is 9. Therefore, the product is 16x squared minus 9. Now that you have recalled how to multiply polynomials, you are now ready to venture into quadratic equations. So let us first define what is quadratic equation. A quadratic equation in one variable is a mathematical sentence of degree 2, meaning the leading exponent on x is 2. So it is a quadratic equation if the leading exponent on x is 2. A quadratic equation can be written in the standard form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. In the given equation, ax squared is what we refer to as the quadratic term, bx is the linear term, and c is the constant term. Now, there are two kinds of quadratic equations. We have the complete and incomplete quadratic equations. Ax squared plus bx plus c is equal to 0 is an example of a complete quadratic equation. As you can see, we have a quadratic term, a linear term, and a constant term. Now, these three are examples of incomplete quadratic equations. Ax squared plus c is equal to 0, ax squared plus bx is equal to 0, and ax squared is equal to 0. Why do we consider them incomplete? As you can see, in the first one, the linear term is missing. In the second one, the constant term is missing. And then in the third one, both the linear term and the constant term are missing. So these are incomplete quadratic equations. Let's have some examples of quadratic equations. Number 1, x squared minus 7x plus 12 is equal to 0. Another example, x squared is equal to 64. As you can see, the leading exponent on x is 2, or the degree is 2. That is why we consider them quadratic equations. Another example, 4x squared is equal to 16. Another one, x squared minus 3x plus 7 is equal to 0. And then for number 5, 2x times quantity x plus 3 plus 7 is equal to 0. This is also a quadratic equation, but it is not yet expressed in standard form. If we are going to simplify this using distributive property, we're going to have 2x squared plus 6x plus 7 is equal to 0. So as you can see, the leading exponent on x is 2. So this is a quadratic equation. Let's proceed to the second column. Now these are not quadratic equations. X plus 1 is equal to negative 5. So this is not a quadratic equation. As you can see, the leading exponent on x is 1. It is not 2. So therefore, this is not a quadratic equation. Same with number 2 example. The leading exponent is 3. Therefore, it is not a quadratic equation. For number 3, if we simplify this, first we get rid of the denominator, multiply the entire equation by the LCD, which is x plus 1. We will get multiply x plus 1 by 1 over x plus 1. So the product is 1. And then multiply x plus 1 by x squared. So we have x squared times x plus 1. Using distributive property, this is 1 is equal to x cubed plus x squared. So the leading exponent now on x is 3. Therefore, this is not a quadratic equation. Same with number 4. This is not a quadratic equation. Same with number 5. Next, if a quadratic equation is written in the form ax squared plus bx plus c is equal to 0, then it is said to be in standard form. Let's have an example. Let's say we have 5x squared plus 3x plus 7 is equal to 0. This is an example of a quadratic equation written in standard form, wherein a is equal to 5, b is equal to 3, and c is equal to 7. A is equal to 5, b is equal to 3, and c is equal to 7. Another example. 2x squared plus 5x minus 3 is equal to 0. It is a quadratic equation wherein a is equal to 2, b is equal to 5, and c is equal to negative 3. Another example of a quadratic equation, we have x squared minus 3x is equal to 0. We don't usually write 1x squared. Therefore, we don't usually write 1 here. But it is understood that the what do you call this? The coefficient is 1. Therefore, A is equal to 1, B is equal to negative 3, and since C is not shown in the quadratic equation, it only means that C is equal to 0. Next, we have 5x minus 3 is equal to 0. Now, this is not a quadratic equation. Why? Because the equation is not of degree 2, or the leading exponent on x is not 2. So, this is not a quadratic equation. Sometimes, a quadratic equation does not always look like the first example. Let's observe the following quadratic equations. First, we have x squared is equal to 3x minus 1. This is a quadratic equation, but it is not yet expressed in standard form. So how do we express it in standard form? Move all terms to the left side of the equation. So if we move all terms to the left side of the equation, it now becomes x squared minus 3x plus 1 is equal to 0, where a is equal to 1, b is equal to negative 3, and c is equal to 1. Another example of a quadratic equation not written in standard form, we have 2 times quantity x squared minus 2x is equal to 5. How do we rewrite this in standard form? It says here, expand and then move all terms to the left side of the equation. If we expand, we get 2x squared minus 4x is equal to 5. After expanding, move all terms to the left side of the equation. If we move all terms to the left side of the equation, it now becomes 2x squared minus 4x minus 5 is equal to 0, where a is equal to 2, b is equal to negative 4, and c is equal to negative 5. Another example, x times quantity x minus 1 is equal to 0. To write or express this in standard form, what do? Expand and then move all terms to the left side of the equation. Because remember that a quadratic equation in standard form must be written in the form a x squared plus bx plus c is equal to 0. So let us expand. X times x, we have x squared. X times negative 1, we have negative x is equal to 3. And then what do we do next? Move all terms to the left side of the equation. So if we move all terms to the left side of the equation, it now becomes x squared minus x minus 3 is equal to 0, where a is equal to 1, b is equal to negative 1, and c is equal to negative 3. Let's continue. Let's say we have x squared plus 5x minus 3. Since this is already expressed in the form ax squared plus bx plus c is equal to 0, then this quadratic equation is already written in standard form. Since it is already written in standard form, we can now identify the values of a, b, and c. Now, a is equal to 1, b is equal to 5, and c is equal to negative 3. Another example. Okay, this is a quadratic equation, but it is not yet expressed in standard form. So, in order to express it in standard form, expand and then move all terms to the left side of the equation. 3x times x is equal to 3x squared. 3x times negative 2 is negative 6x is equal to 10. You can use transposition to move all terms to the left side of the equation, or apply the addition property of equality. How do we apply the addition property of equality? In order to express this in the form ax squared plus bx plus c is equal to 0, the right side of the equation must be equal to 0. In order to make the right side of the equation 0, what do? Is we add negative 10 on the right side of the equation. So we are applying addition property of equality. If we add negative 10 to the right side of the right side of the equation now becomes 0. Now, on the left side of the equation, to maintain the balance of the equation, we must also add negative 10. So whatever you do on the right side of the equation, you must also do on the left side of the equation to maintain the balance. Okay, now it becomes 3x squared minus 6x minus 10. Our equation is now expressed in standard form. So we can now identify the values of a, b, and c. A is equal to 3, b is equal to negative 6, and c is equal to negative 10. Let's have another one. Okay, using FOIL method, we have 2x squared minus 2x plus 5x minus 5 is equal to negative 6. Let us first combine the like terms. So we have 2x squared minus 2x, let's combine the two like terms. So again and again, bring down 2x squared, and then what is the sum of negative 2x and 5x? The sum is positive 3x minus 5 is equal to negative 6. So apply the addition property of equality. To make the right side of the equation 0, what are we going to do is we add positive 6 on the right side. So if we add positive 6 on the right side, we must also add positive 6 on the left side of the equation. So this now, the right side now becomes 0. And this is 2x squared plus 3x. And then combine like terms, negative 5 plus 6, we have positive 1. Now our equation is expressed in standard form. A is equal to 2, B is equal to 3, and C is equal to 1. Another one. Okay, so this is 2x squared is equal to 7. To write it in standard form, apply the addition property of equality. Make the right side of the equation 0 by adding negative 7 on the right side. We must also add negative 7 on the left side to maintain the balance. So the right side now becomes positive 7 plus negative 7, that is equal to 0. And the left side now becomes 2x squared minus 7. So this is now our quadratic equation in standard form, where a is equal to 2, b is equal to 0. Why 0? Because there is no linear term. And c is equal to negative 7 because the constant term is negative 7. Let's have another one. 4x squared is equal to 1/5 x. So first we must get rid of the denominator 5. So to get rid of the denominator 5, we multiply the entire equation by 5. 5 times 4x squared, we have 20x squared is equal to 5 times 1/5 x. We get 5 times 1, 5 divided by 5, 1. So 1x, or simply x. So we now have 20x squared is equal to x. Apply addition property of equality. To make the right side of the equation 0, we will add here negative x. So if we add negative x on the right side of the equation, we must also add negative x on the left side of the equation. Now the right side of the equation becomes 0, and then the left side we have 20x squared minus x. Now our equation is expressed in standard form. A is equal to 20, B is equal to negative 1, and C is equal to 0 since there is no constant term. Okay, let's have some practice. Identify if it is quadratic or not quadratic. Number 1, okay, not quadratic because the leading exponent on x is not 2. Number 2, okay, that is a quadratic equation. Number 3, not quadratic. Number 4, quadratic. Number 5, also quadratic. Let's continue. Given the values of a, b, and c, write the quadratic equations in standard form using x as the variable. So if a is 3, b is 6, c is negative 1, the quadratic equation in standard form is 3x squared plus 6x minus 1 is equal to 0. Number 2, if a is 1, b is 0, c is 25, the quadratic equation in standard form is x squared plus 25 is equal to 0. Number 3, if a is 1, b is 1, c is 0, therefore the quadratic equation in standard form is x squared plus x is equal to 0. Number 4, if a is negative 2, b is negative 5, and c is 3, the quadratic equation in standard form is negative 2x squared minus 5x plus 3 is equal to 0. Number 5 is if a is 1, b is negative 1, and c is negative 20, therefore the quadratic equation in standard form is x squared minus x minus 20 is equal to 0. Next. Okay, to write this in standard form, number 1, all the terms are already on the left side. So we simply have to rearrange. The quadratic term must come first, negative x squared, followed by the linear term, 5x, and then followed by the constant term, negative 4. Therefore, the quadratic equation in standard form is negative x squared plus 5x minus 4 is equal to 0, where a is equal to negative 1, b is 5, and c is negative 4. Okay, number 2, move all terms to the left side of the equation. So we have x squared plus 2x plus 15 is equal to 0. So the standard form is x squared plus 2x plus 15 is equal to 0. A is 1, b is 2, c is 15. For the last number, in order to write it in standard form, we need first to expand. X times x, x squared. X times 5, positive 5x. And then you bring down negative 2x is equal to 0. Combine like terms. 5x and negative 2x will give us positive 3x. Okay, therefore, the quadratic equation in standard form is x squared plus 3x is equal to 0. What is the value of our a? A is equal to 1, b is equal to 3, and c is equal to 0 because there is no constant term.